All right, so yesterday when we looked at electron configurations, we used the diagrams that showed increasing energy for your orbitals or your sublevels going up the page from the lowest energy at the 1s sublevel and going up. And we worked out ways to write the configurations, basically just listing each sublevel, and then as a superscript, we're putting in the number of electrons in that particular sublevel. So this was bromine. Bromine has 35 protons in the nucleus, 35 electrons. And the only thing we had to kind of be careful of is we get to the 4s sublevel. And remember in the game, you had to fill in the 4s sublevel before you could unlock 3D. And that's because the 4s sublevel is slightly lower energy than the 3D sublevel. But interestingly, the 3D sublevel is still considered interior, so closer to the nucleus than the 4s sublevel. So we kind of flip-flopped the order here so that we could put all of the third principal energy level orbitals together. And then we bumped those fourth principal energy level orbitals outward. And I put a star by those just to remind you that those are probably the most important electrons in the atom because they're farthest from the nucleus on average. So those are the electrons that are going to be involved in bonding. And that's the real purpose for doing an electron configuration, is to make some predictions about how that particular element will bond. And the outermost electrons are the ones that are most likely to be involved in bonding. Okay, so today's sheet has a slightly different orbital diagram. And at the top of your sheet, oxygen should be done for you. It's the same idea. We've got the sublevels listed out in order of increasing energy, but now we're just working from left to right, okay? So if you go back to the previous page and you go upward, they're going to be the same order that we see here from left to right. So it's a slightly more simplified orbital diagram, but we use the same rules. So let me bump back over here for a second. So our three basic rules for filling out an orbital diagram: we fill the lowest energy orbitals first. That's the Aufbau principle. Here we're going to start on the left and work our way to the right. Orbitals can hold at most 2 electrons, so they could have a single electron or a pair. And then the third rule is that orbitals of equal energy fill first with single same spin electrons, and then they pair up. So you fill in an entire sublevel with single electrons, for example, like the 2p sublevel here. And then if you have more electrons, then they pair. So let's take a look at what that would look like for aluminum. This is going to be our first example. So with all of these, the first thing you need to do is find aluminum on the periodic table. Aluminum is right here, atomic number 13. And so I'm going to go ahead and I'm going to jot down 13 so that I know how many electrons to put in the diagram. And I'm just going to work my way from left to right like I was before. So we're going to have electron number 1 and 2, 3 and 4. And then 5, 6, and 7 go in as single electrons. And then 8, 9, and 10 will pair up. So again, electrons have a quantum property called spin. They can be up or down spin. So each little half arrow represents an electron. So that got us up to 10. Electron number 11 and 12 go in the 3s orbital. And then the 13th electron is out here in the 3p sublevel. So our configuration is going to be 1s2, because the 1s orbital has 2 electrons, 2s2, 2p6, 3s2, and 3p1. Okay. And I like to go ahead and just kind of bracket out the electrons in the same principal energy level. So in the first principal energy level, we just have the 2 electrons. In the second principal energy level, we have actually a total of 8 electrons. And then in the outermost third principal energy level for aluminum, we have 3 total electrons. And again, those are going to be kind of our most important electrons because they will be involved in bonding. So very similar idea. I think if you have the orbital diagram in front of you, it's just a matter of counting them out and making sure that your pairs and unpaired electrons are correct. All right, let's do argon. Argon is a noble gas, way on the right-hand side of the periodic table. It is atomic number 18. So I will go ahead and work this out on the screen. You can try it on your own. If you need a hint, just take a look at the screen. So if you've done this one correctly, we should end at the 3p sublevel. It should be completely full with 6 electrons. So the configuration is 1s2, 2s2, 2p6, 3s2, 3p6. And again, if I want to bracket them out by principal energy level, I've got the 1s principal level, I've got the second principal energy level, and then for argon, we've got 8 electrons in the outermost energy level. All right, so I'm going to skip fluorine for now. You can come back and do fluorine in a moment. If you flip to the back of the page, I want to do cobalt, because this is one that starts to involve that 3D orbital, which can be a little bit tricky. So cobalt is a transition metal. It's right near the middle of the periodic table. It is atomic number 27. And again, this one's on the back of your handout. So again, if you want to go ahead and start filling in your 27 electrons, you can. If you want to look at the screen for a hint, you can do that. And then I would wait on writing the electron configuration. We'll work through that together. And if you have things counted out correctly, you should be in the 3D sublevel. And it should have 1, 2, 3, 4, 5, 6, 7 electrons in the 3D sublevel. So this is one where we want to pay attention to this 4th principal energy level. Even though it is lower energy than 3D, these 2 electrons would be considered outer, the outermost level. So when I write the configuration, there's just that little swap in order that I want to be aware of. So I have 1s2, 2s2, 2p6, 3s2, 3p6. And instead of writing 4s2 next, I'm going to go ahead and list my 3d electrons because I want to keep those together with the other 3rd principal energy level electrons. So it will be 3d7. And then I'm going to go ahead and write the 4s2 last. So again, if I'm bracketing out my principal energy levels, There's your first level, your second level. Your third level includes those 7 3D electrons. And then I would consider the outermost energy level the fourth principal energy level with 2 electrons. Okay, so I'm going to give you guys some time here in class to continue working on that. I want to also preview what's coming next. So if you flip to the last page in your packet, you've got a bunch of different element boxes. And you should have aluminum filled in on your sheet. I wrote it in pencil before I copied it. So what we're going to do on this sheet, and you'll have time to work on this in class on Thursday, okay? So some of you will be here Thursday, some of you won't. Either way, I want you to try to finish this sheet on Thursday, and you probably will get started on it in class today too. But all that we're doing here is taking the configuration for aluminum. So the way I came up with this was I took aluminum's configuration, and instead of writing the configuration left to right, whenever I get to a new principal energy level, I just put it below on its own line. So that's what we see here for aluminum. 1s2, 2s2, 2p6, 3s2, 3p1. I've written it like that because each line then represents another energy level, principal energy level for aluminum, okay? So for argon, these are actually listed alphabetically by symbol, okay? So argon we also did on the previous page, right? It looked like this. So I'm just gonna write 1s2 on the first line. And then I also want to go ahead and note the atomic number in the upper left corner. So I'm going to write 18. I'm going to write the full name, argon. And then I'm going to list the electron configuration, putting each subsequent principal energy level on its own line. So 1s2 is up by itself, 2s2, 2p6 is on the next line, and then going back on the third line we're going to have 3s2, 3p6. And that is it for argon. Okay. If I had a fourth energy level, I'd want to put it below. So this activity is going to take some time. Really, Thursday and Friday in class, you're going to have a lot of class time to work on this. What we're going to end up doing with all of these element boxes, once we have the configurations and names and atomic numbers, we're going to cut them out and you're going to paste them on a big periodic table. So you're going to locate them in the correct position. And what we want to start to do is take a look at these electron configurations, where they are on the periodic table, and look for trends. Okay. So it's important that you're accurate on this sheet, and there are some different strategies to do it. What I would recommend is you're going to have all of these done, the practice with electron configurations, by the end of the day today. What you can do is find each of those elements, and you can find the corresponding box and take care of those. That'll actually knock out a good number of the elements that we have here. And then we also had the handout from a couple days ago, or one day ago, I guess. So you've got some examples that you did on this handout. You could also go ahead and do those first. And then again, Thursday in class, you will have time to finish up the rest of the examples on this sheet. Okay? Any questions? All right, so first priority today would be to finish up this sheet, okay? I will put the answers up on the screen. For those of you who are at home, you can find those on today's agenda post to make sure that you're doing them correctly, and then you can move on to this sheet. All right.